All right, so we're finishing up our lesson for 2.5 part B. We're going to be solving rational equations still. And just like yesterday, we need to first investigate our denominators. Now this one's a little complicated because while this denominator doesn't give me any trouble, this one looks a little weird to me. And then this one looks like it's factorable. So let's take care of that one that we can factor right away. The y squared minus 4, better name for that in factored form would be y plus 2 times y minus 2. It's important that you guys do factor anything and make it look like a normal polynomial factor so we can move on when it comes to the LCM. Now, this one, I'm going to show you a neat little algebra trick. It doesn't really look exactly like the factors that I already have in the problem, and you don't want to add additional factors to your problem if you don't have to. So, a trick you can do in algebra is if your term seems to be backwards like this one, you can just simply factor out a negative from it. So, if you were to factor out a negative from 2 minus y, that changes everybody's sign, right? So that becomes a negative 2 and a positive y. So this term is really the same thing as negative quantity y minus 2. I like the look of that better because it has some common factor business going on in this question now. The other thing, though, I want to point out to you is this term already has a subtraction sign in it, and now you just factored out another negative from it. So essentially you have a negative times another negative, and in math when that happens, that means we have a positive. So forget this denominator. I'm going to be using this denominator for that fraction. All right, so I kind of made a mess of my problem, but it's going to pay off in the end. Real quick, tell me about the answers that I can't have. What could I not get for y because I'd get a divide by 0 situation? What is this? 2 and negative 2. Very good. If either of those show up, I got to cross them off and call them extraneous. All right, so big parentheses around the whole problem. If I start making a list of every factor that shows up in my denominators, I see a y plus 2. Does anybody see anything else? A y minus 2. And I know that they happen to show up multiple times, but never in the same fraction. So this is your least common multiple. I'm going to multiply it by every single term. And this problem already is a hot mess, so I'm going to try to take my shortcut on this term. Here's what my shortcut looks like. Instead of writing down everything in the problem, I'm only going to write down things that don't cancel. So like for instance, when I distribute to this first term in the problem, I know the 2 is still going to be there, but won't the y plus 2 cancel with the y plus 2 from the LCM? So I'm not going to write that part down. But what do I have still? The y minus 2 is still there. So I'm not even going to distribute it. I'm just going to write it down like 2 times y minus 2. I'll do all the distribution on the next line. Now we decided this sign changed to a plus because of that double negative thing. So this numerator still has a y in it. But the y minus 2 is going to cancel with the y minus 2 from the LCM. But you still have the y plus 2 on that term. Oops, wrong color. And then obviously we still have an equal sign. For the last term, I still have the quantity y squared plus 4. But look what happens to his denominator in the LCM. They totally cancel. So y plus 2 is gone, y minus 2 is gone. So I don't have to multiply that y squared plus 4 by anything. So now I'm on my distribution step. I do have what appears to be a quadratic, but I think it's going to cancel itself out in a minute. So this becomes 2y minus 4 plus y squared plus 2y. And then it still equals y squared plus 4. Oh, this is nice. So what I thought was a quadratic at first, turns out it's not a quadratic anymore because the y squared terms will knock out. So now you just have like a traditional linear equation. So you're going to add up your y terms and you're going to get 4y. I'm trying to save you a little room here, guys. So I'm just going to go ahead and add the 4 over here. So 4y equals 8, which means y equals 2. And you're like, woo, box it in and walk away, right?
Yeah.
No, why not? It says right here, you can't have y equals 2. Cameron, you're the one who told me that. So we're going to say this is an extraneous solution. So what does that mean? I just crossed off the one solution I have. So your solution is that you have no solution. Which I know everyone thinks that's like lame and, oh, I wasted all my time. No, the fact that you have no solution is a solution. Okay? So that was fun. 4 isn't nearly as fun as that one, but that's okay. We'll still do it. Real quick, we've learned our lesson about the extraneous factor. So tell me quickly what I can't have for x because it would give me a divide by 0. There's two of them. I can't have -3 and I can't have 0. Very nice, because that would give me a problem in either one of my denominators. So big parentheses around the whole problem. If I look at my denominators, remember x is not the same thing as x plus 3. Not even close. So when I ask you, what are all the terms that I have to knock out, you're going to tell me those. You're going to say you have to knock out an x and an x plus 3. So when that gets distributed to every term, again, I encourage you guys to take the shortcut. The next one we do, I'm not going to take the shortcut, so you can see what it looks like to not take the shortcut, because we have a lot of room on that one. So, all right, so this one, when I multiply the first fraction by the LCM, the 60 is still going to be there, but aren't the x's going to cancel each other out? But you still have the x plus 3. Make sure you leave him in parentheses as well, unless you've already distributed. All right, there's a minus sign followed by a 60 for the next term. However, the x plus 3's will cancel out, but you still have the x from the LCM. And then in the last fraction, some kids tell me the 1's cancel out, but y'all know that 1's don't ever truly cancel out. So you have an x times an x plus 3. Now let's take care of all that distribution. This time I think we do have a quadratic. That's a pretty cool one. Looks kind of nasty at first, but I think it's alright. So the 60x's cancel each other out because they're on the same side there, 60 and minus 60. So you have a positive quadratic term over here on the right. Let's bring everything to the right because of that positive. Alright, so we have x squared plus 3x. You would have subtracted the 180 over. Ah, yes, factors of 180 right on the tip of your brain, aren't they? So the fact that 180 ends in a 0 tells me like it's a friend of the 5's family, right? And the fact that I need them to be 3 units apart from each other for the factoring, I'm thinking you got to go into the teens. So try like a 15. Is 180 divisible by 15? But, oh, 15 times what? There's our winner. Okay. So let's try a positive 15 and a minus 12. That would factor nice. Adds up to 3 in the middle like we wanted. So remember, guys, you're trying to solve your factors, give me solutions. So this one gives you x equals negative 15, and this one will give you x equals 12. Neither of which were my excluded values from the beginning of the problem. So I'm going to box them in and walk away. We don't test this section until next Friday, so if you find yourself on next Friday's test with like 4 minutes at the end and you're like, I wonder if I got that rational right, you can check it. And I'll actually share another way for you to check it later. All right, this one, there's no factoring on the denominator, but my denominators have several things going on. Okay, real quick, tell me what I can't have for solutions. It actually starts off very similar to the last question. Can't have 0 and negative 3. Now, the fact that this one has a denominator of 4, there's no algebra there, so you don't have to worry about like, oh, what's going to make it extraneous, but it is still a fraction, and I don't do fractions today. So now talk to me about what's everything in a list that I need to knock out. A 4 and an x plus 3. I don't bother putting monomials in parentheses, but you can if you want to see them separate like that. All right, so this example, I'm going to show the long way. This is the way that frustrates kids sometimes because they're like, oh, so much writing. So here's my thought. If you're going to get it right the shortcut way, keep doing it. If you're like, nope, I make mistakes all over the place, don't do the shortcut. All right, so when I do the long way, I rewrite the problem, but I expand it out with space in front of each of the terms. So I leave a space, and then I'm going to write the first term. And then I'm going to leave another space, and I'm going to write the second term. And then like leave a space, and I'm going to write the third term. And then in front of those terms, I'm going to write the red LCM that we came up with. So you can see why some kids don't like this method. They're like, this seems like a lot. All right, so the other thing I'm going to do is anytime there was already a polynomial, oops, I wanted black. All right, anytime there was already a polynomial, like here, the x plus 3, I'm going to put parentheses around those just so I can see them in terms of their factors. So what you're going to do now, and this is the part you guys do in your brain, but now we're just seeing it on paper. Each one of these distribution pieces are their own little tiny simplification problem. So in each of these bubbles, you should see some cancellation because the whole point of this is to knock out my denominators. So look at that first bubble. What's going to cancel? The x will cancel. So like I'd take another color pen and I'd scribble out the x. So what do you still have? A 4 times an x plus 3 times an x plus 3. You have 3 things that you're trying to multiply together, and this is where kids make a mistake. They try to do it all at one time. Fortunately, they make a mistake when they do it. You can only really technically multiply 2 things at a time. So leave the 4 in front, but do go ahead and multiply the x plus 3 times the x plus 3. So we'll call that x squared plus 6x plus 9. Save the 4 for the next step. All right, next multiplication bubble. There's a plus sign, and then you got another bubble of what cancels? The x plus 3's are gone, so I'm going to scribble those out. And then I notice I still have a 4x times a 7x. That I think we can write as a 28x squared. And then that last bubble, just the 4's cancel. So this is another case where you have technically 3 things that you're multiplying together. So I'm just going to leave it for now as 23 times x plus 3 without the distribution yet. Because I'm about to distribute a whole bunch of stuff right now. All right, here we go. Distribute, and then this guy as well. So we have 4x squared plus 24x plus 36. You still have a plus 28x squared. Let's see, here you have a 23x squared plus 69x. Now this is one of those, like, there's a lot of algebra in this question and a lot of computation where I could have made a mistake. So if you notice like a classic Abruzzo thing where like I don't add right, you let me know. Y'all, we have a quadratic and it's kind of a mess right now. So I'm going to go ahead and simplify the left side. I'm going to bring things over to the left side next time. So I'm going to combine these, make this a 32x squared. And then we still have the 24x and 36. And I also have a equals 23x squared plus 69x on the right side. Okay, now let's start moving things around. I know many of you are capable of doing that in far less steps. But like if this was a test, I don't know if it's worth it. All right, finally we get our quadratic in standard form. And my piece of advice to you is if you're on the test next week for this section, you should end up with either a linear that you can solve easily, because it's linear, or a quadratic that can factor, or solve simply. If you end up with a quadratic and you're like, oh man, I got to use quadratic formula, something's wrong. Okay, I didn't give you an irrational one. So 9x squared minus 45x plus 36 equals 0. I wasn't super excited about that quadratic at first, but then I took a closer look. You notice anything about that quadratic? Those coefficients? They can all be divided by a 9. And because it's an equation and you're dividing by a number, that 9 is getting out of the problem. You're dividing everything by 9. So your new quadratic, much better. X squared minus 5x plus 4. Solve that baby for me. Like, I could solve that in my sleep. All right, so x equals 4. And x equals 1. I lost track of my slide way at the top. Were these my excluded values at all? They were not. Okay, so keep them both. So that bubble technique that we drew obviously is very colorful and pretty to look at. It's a lot of writing. It's the long way, quote unquote. But man, is it effective. So like as you're practicing this, I know you probably haven't started the homework for this yet, and I don't blame you. But next week when you start this homework, or possibly this weekend, maybe if you look at a question and you're like, this looks really difficult, or if you've tried it and you've gotten it wrong and you can't figure out why, write it out the long way. We are going to skip this question until later because I want to give you guys lots of time on your review. Can you please find your review? Found it. I will find it as well. So unfortunately the review and the test go in different orders, but I like the order of the test. Here's the order of the test. It does start off with 1.5, the transformations. And then it has 2.2 and 2.3, so the other old topics. And then it has the new stuff, the graphing rationals with the asymptotes. That's at the end of the test. So the reason I like that order is because I am done with 1.5, 2.2, and 2.3. I will not be testing them again until the final. Okay? So, not that I'm saying you're going to run out of time on this test, but, you know, sometimes things happen. You get stuck on a question. Like, I'd like you to do those sections first. Okay? Because I am done. And you know how done I am with transformations. I was so done, I lied and said I was done, and I wasn't done, and now I'm done. Okay, I am really going to be done with transformations this time. So let me give you guys a little bit of insight as to, this is what I kept seeing problems with. So let's see, maybe they fixed themselves. I don't know. I'm going to write a few things just on this blank slide. And I'm wondering if you guys could tell me what they mean. Let's start with this.
Reflection over the y-axis.
Thank you. So notice, whoops, reflection over the y-axis. Right away, Cameron knew that was a y-axis reflection because anything inside of the function with the x component is a horizontal movement. So if you're reflecting horizontally, that means you're reflecting over the y-axis. Very good. It's negating all of your x's. So that's something that you could visually see pretty easily, right? What about when you throw a 3 inside?
Horizontally stretch.
I was worried you'd say that. Oh, okay. We knew it was horizontal. That was good. Horizontal. It's a compression.
How is it compression?
Yeah. If you want to just,
what?
In layman's terms, it's opposite. But the idea is to get back to the original function, you'd have to third everything to undo the factor of 3. Okay?
Crazy.
So we do have to somehow in our brain remember anything around the x is like opposite of what I think it should be. That's very confusing, I know. The x is so weird. All right, so what about 1/4 in front? Very good. A 1/4 in front would be a horizontal stretch of 4. So I don't need you necessarily to graph anything, but let's say I graphed you something that looked like, you know, this. And I told you that you had a couple of pertinent points on this guy, okay? Let's talk about the horizontal compression of 1/3. Where on your graph would you be looking to look for a horizontal compression? What's going to change?
Your x-intercept.
The x-intercepts, thank you. The x-intercepts, all of these guys, you're going to see them shrink in by a factor of 1/3. So like for instance, if this was, I'm just making this up, if this guy was -3, and this guy was 2, and this guy was 6, every one of those would be shrunk in by a factor of 3 or 1/3. So like that -3 would become a -1. That 2 would become a 2/3. That 6 would become a 2. So you're going to see that. Would your height be changing in any way?
No.
Doesn't get any taller or shorter. Okay. Good to know. So can you do that for me on your test the right way tomorrow? Yeah. Good. Can you look on your review, look at the very bottom of that section real quick with me while we're on the topic. So here's your original. And then we have 2 transformed ones. I would like you to give me words, but also function notation. What happened?
Did it shift to the left or the right? Why does it look like it shifted?
I'm hearing the word stretch by some people. Okay, this, good, is a horizontal stretch of 2. And to take your advice, Cameron, I'm going to look at the x-intercepts. They used to be at 1 and 4, and now they're at 2 and 8.
Yeah, but why'd that other point move?
The x did. Yeah. All the x's change. It's just, it's a lot easier to see on the intercepts, right? So I like that you called it a horizontal stretch of 2. Now for all of the points, what does that look like?
-1 or 1 just 1/2.
Like this?
Yeah.
Very good. Okay. We know they're weird. All right, what about this one? What's the transformation here? Vertical stretch of 2. So notice the x-intercepts did not change. They're still at 1 and 4. So there was no horizontal movement there. But if you look at this low point, this minimum, it was at -2. And now it's down here at -4. So what does that look like for a function if you vertically stretch it by 2? Very good. So f of x is the same, but she says we should throw a 2 in front of it. Nice job. Okay. You're going to get it this time, right? Can we back up to this question, though? I'm a little worried about this one. So the last time we tested this one, the thing that made me sad was some of you didn't know what the parent function looked like, and then some of you dropped the parent function in the middle of your algebra, and that was very sad. So don't do that. The parent function is the cube root function. So we're going to start writing that out. Y equals, except I don't know the stretch. That's what I'm trying to find with all my work. So I'm just going to put an A down. And then we have the cube root, don't lose the cube root in the index, of x, but keep reading. It says it was shifted to the left 3 units. What would that look like if you shifted to the left 3 units? Good, +3. And then it was shifted up 4. So outside of the radical, you're going to see a vertical shift of up 4. I want everyone to start their problem with this. That is the key to the problem right there. We're going to come back to that at the end of the problem. Now you keep reading the question, and they give you a point that you can utilize. They said when x equals 5, y equals -12. Use that point on your next line and plug in -12 for y. I still don't know a. I still have the cube root of, but now I know that x is 5. Okay, and then I'm still a little nervous because I saw some people do some weird things with their math. I'm trying to solve for a. What would be your first step?
Subtract 4.
Okay, yeah, move the 4, subtract the 4. I have a lot of kids who try to add these terms together. That's not a thing you do in math, guys. That's an A and a non-A. All right, so we have a -16 equals a. Now, I wouldn't mind if you guys do calculate what this is. This is the cube root of 8, which is 2. So then your final step would be to divide by 2 on both sides. And y'all just found a equals -8. Cool. Remember this first line you guys gave me? This was an almost perfect answer. The only thing you got to do now is throw the -8 in place of the a. So -8, cube root, x plus 3 plus 4. Okay, that's what I'm looking for in that question. And this is a very helpful example of what you're going to see tomorrow, okay? I think it's the same parent function even. You're welcome. Any other transformation business? Now, I know we made a big deal about in order. If you get the order wrong, you're messed up. The one on the test is very gracious. It's one where really the order doesn't matter. So we're trying to be really kind to you on that question. It is best if you can do them in order, but I think you guys have seen examples where order doesn't really matter. And I think Taylor's hint that she always uses is she just goes left to right. And if there happens to be distribution, she distributes it usually right away. And I think that's a good way of thinking about it. Okay. All right. I'm going to skip this stuff for now just because we've been hitting it hard in class for the last 2 days. Plus, it's the newer stuff, so it's fresher in your mind. And like I said, I'm not touching this old stuff anymore. I'm done after this test. Done. Done, done, done. All right, here's what I want to see. Now remember, guys, this is a no graphing calculator test. So everything is, you can compute stuff on a scientific calculator, but all of the graphing component is up in the old noggin. Here's what I would like to see from everybody. On number 10, I want you to figure out what your lead term is. This would help your teacher quite a bit if you wrote this part down. Because if this was your mistake, I'd be able to kind of follow it through your work. Because if you mess up this part, everything's going to be wrong. So your lead term, you have a -4x squared times an x to the 3rd power times an x. So think about that. You have a -4x squared times an x to the 3rd power times an x. What do you have? 6th power. Yes, -4x to the 6th power. I know. So if that's where you messed up, at least I can carry it through for the rest of the test, and I can go with your weird logic, okay? So what is the degree of that? 6, and the lead coefficient is, now I see it's a -4. The other thing I would suggest you do is draw me a little sketch of your ends, like just how you guys would point with your fingers. It goes up, up, down, down, up, down, down, up. Draw me that. So this is an even power with a negative coefficient, So I'm hearing the ends go down, down. It's a cousin of a quadratic, right? So they either go up, up, or down, down based on the sign. I'm going to keep that there just so I can answer end behavior quickly in a minute. All right, zeros. If you take each of your factors and you set them equal to 0. Now this one gave some kids trouble. If you were to solve that, you still get x equals 0. But because of the second power, that means it shows up twice. Multiplicity 2. Very good. And then I kind of crossed this off by accident. But this factor gives you an x-intercept at 1. But how many times does that show up? Multiplicity 3. And then the last one just shows up 1 time, so -7. So, end behavior. You know I'm asking about left and right end behavior, so at least draw that for me. And I just heard from a bunch of you that this one went down, down. So what does that look like over here? Negative infinity and negative infinity. Very good. So the more you write down so I can follow your logic, the better off you will be as far as scoring goes. Plus, let's be honest, you're less likely to make a mistake if you jot everything down. If it's all up in your head, weird things happen in your head sometimes, okay? Okay, so good question. So if it was an odd with a positive coefficient, then the left side would go down and the right side would go up. If it's odd with a negative coefficient, the left side goes up and the right side goes down. So this odd is a very distant relative of a line. So if you get confused, think of like, okay, the line y equals x would look like this, right? That's all the relatives of the odd degree. They go down on the left and up on the right. The exception to that would be a negative coefficient would reflect it. Okay. Got it? Okay. Good questions. All right, this next one. I want to see you guys factoring this to the what point you can get it to. So last time I had a lot of people factor this and they got to this point. They were like, oh, x squared minus 8 and x squared minus 4. And then they wrote that down right here. And then I wrote a note. I said, keep going. There's one of those factors that I expect every PreCalc student on the planet to factor a little more. Which one factors more easily? Yeah, that guy factors beautifully. So factor them. All right, so the x squared minus 8, I don't care if you continue on and try to muscle with that one. That's not a nice factoring problem. But for sure, I want to see x plus 2 and x minus 2. Oh, I skipped the two easiest questions on the test. Possible number of real zeros. You could have up to 4, and we're totally going to have 4, so make sure on the next question down here you write down all 4 of them. Number of possible turning points is 3, because it's 1 less than the degree. A few of you told me 4 here on the last test, because you told me there's 4 zeros, which you already told me here, so don't tell me that again. I want to know what they are. So if you think about setting all of these equal to 0, you're going to get positive and negative 2. And then what would happen if you took x squared minus 8 and solved it? Well, you're going to be square rooting 8. And then I expect you guys to reduce that for me. So positive and negative, this is like 4 times 2, right? So 2 squared to 2. So you did list out 1, 2, 3, 4 solutions, which is what I was looking for. Oh, this question. Okay, first of all, is this an even or odd degree? Okay, how do you know it's odd? Yep, the little end behavior guy here, right? So this is odd, and then it says y. I would just do this. I would just draw the ends, and it would be like, because they go in opposite directions, okay? So remember, no calculator on this test that graphs. So you'll be seeing a picture like this. If on your test tomorrow, if you just can't see what's going on in your picture, because I will be honest, the one on the test is a little dark to look at, like the grayscale in the back that kind of blurs it. Just bring it up and we'll muscle through that part together. List my zeros for me. I see 1, 2, 3 places where something happens around the x-intercept, or x-axis, excuse me. What are they? -5. We'll come back to the multiplicity in a second. 0, good. And 2. So those are the 3 places where something happens along the x-axis. And then where are the multiplicities at, Adam? Go ahead. All right, so multiplicity 2 at -5. And 0 has multiplicity 2. And then y I'm just looking for you guys to refer to the fact that it bounces off the x-axis. So I'll take a lot of answers here, guys, but if you say, like, it bounces off the axis, or it touches the x-axis, or Mrs. Hoffbauer says it kisses the x-axis, same thing. So now this is the line where people skip this line, and I wish you wouldn't, because this is the key to the problem. You're going to start by writing out your equation with y and x and k as variables. They use k this time instead of a. It doesn't really matter, though. So y equals k times, now I need to see all of your factors, including their multiplicities. Ready? One of your zeros was at -5, so what's the factor that came from? X plus 5, and then it's squared. Why? Because of that multiplicity business. Good. Now, for the 0, if you wrote x minus 0, I love it. I do it too. I like to keep consistent with my format, but if you just wrote x squared, that's totally fine. Don't lose the squared, though. And then there's one more 0 at 2, so his factor is x minus 2. Good. This is the key to the problem. So let that be your first line. Now we're going to go back and realize they gave me another set of clues. They said, use the clue of x equals 2 when y equals 720. K is still unknown. We know that. What was it? X, -2? Now, you do have a scientific calculator, so it's not like I'm going to make you do all the computation in the old noggin, because this one's kind of gross. But if you were to type this, or mentally calculate this, this comes out to a -144. So you got a -144 times k, so y'all got to divide by -144. And it should be a pretty decent number, and it happens to be negative. So y'all just found k is -5. Go back to this picture. Does that make sense for the picture? That you have a coefficient of -5 if your left end goes up and your right end goes down. That does make sense. Yes, ma'am.
So why is it
Yes, yep. Anytime you see the bounce, you're going to throw a squared on that factor. Yep. So -5 is in front. We're going to go back to this very first thing you guys wrote down. This is the key to the problem, right? Plug a -5 in for k, and then everything else is just rewritten as it was. So x plus 5 multiplicity 2. You can keep writing x minus 0 multiplicity 2, but Adam said he wrote x squared. I like that too. And then x minus 2. That one doesn't have multiplicity. Whew. What a hoot of a question.
Did you write -5x squared?
Yeah, that's what I wrote on my key. I just didn't do it this time. I wrote a lot of things on my key. Not all of them are legible. That's what I found out. All right. Now this is the other old section. So I actually think you guys did a really nice job with long division. But I can go through it if you want. I'm more interested in this question, though. Oops. This one. Yeah. That's probably the one that I marked wrong the most. Okay. So they give you some clues in this question. They want me to write a polynomial in factored form, so they want me to leave it in factors. But the only catch is you can only have real coefficients. And there's another catch to this problem. They told me I have zeros at -5, 4, 11i, and there's a ... because you're supposed to know that there's also one at -11i. This is the conjugate rule. They come in complex conjugate pairs, and it will be an easy monomial like this one is. It's not going to be those horrible binomials that some of us were working with recently, and we're like, I hate those. Me too. Okay, so now what I'm going to do is I'm going to take all those zeros and I'm going to write them in factored form. So a 0 at -5 would be a factor of x plus 5. And then a 0 at 4 would be a factor of x minus 4. X minus 11i and x plus 11i, yep. And if this is what I wrote down, a teacher would be very sad because that means I can't read. It does say real coefficients only. So these two right here, these are not real coefficients. There's an I in each of them. So you're going to multiply these together. You're going to FOIL these together. But it's going to work out beautifully because when you multiply complex conjugates together, they turn out beautiful. All right, so I'm going to keep the x plus 5. I'm going to keep the x minus 4. But what happens when I FOIL this together? I get x squared. The outside-inside arches are going to cancel out, right? That's what happens with conjugates. And then negative 11i times positive 11i is negative 121i squared, which is negative 121 times negative 1, so it's plus 121. If you guys have figured this out yet, this might be a good moment to point out that whenever you multiply complex conjugates together and they're monomials like this, they turn out to be what we call the sum of two squares. And you stop. Some of you last test were like, I'm going to take this and I'm going to factor it again. And I was like, why'd you do that? So, hey, real quick. If I multiply these two conjugates together, what would it become? Yeah. What would... I can't think all of a sudden. All right. What would this one become? Yeah. So if you start recognizing that you're expecting that pattern, it'll cause a little less stress for you on your test, I think. All right, so that is the end of the repeating sections. Oh, we have time. Good job. Do you want to go back to the long division or synthetic division? The long division?
Yeah, synthetic division.
Okay, long division real quick. This one. Has to be done through long division because your divisor is a trinomial quadratic, so yucky. I like to put the divisor in parentheses. It's a pretty decent sized divisor, so you are going to be finding that you don't have as much work as you think you have. Now, this time on the test, I know last time you probably were like, oh, I got no remainder, that's nice. It won't happen this time. You should get a remainder, okay? So, divide the lead terms first. So, 4x to the third, you're dividing it by his lead term of x squared. And you're getting a 4x. That gets written up here at the top where your quotient's going to go. Now you multiply the 4x into the whole divisor. Make sure you distribute it. So you get 4x to the third plus 8x squared minus 20x. And this is the step where I saw a couple people forget something very important. Parentheses, because you are going to subtract this baby. So lead terms cancel. 3 minus 8 is negative 5x squared. And then negative 5, this becomes a plus 20, so plus 15x. You do have to go through one more round of long division, so we will. So the negative 5x squared, now he's being divided by the x squared. And that's where the negative 5 is coming from, thank you. Now the negative 5 gets multiplied in. Alright, let's see here. Negative 5x squared minus 10x. Plus 25. And again, very important you guys include, parentheses here before you do any subtraction. If you only have like one pen in your arsenal, this subtraction step with what I'm doing in blue, if you could do that in another color, amazing things will happen to your efficiency, okay, and your accuracy in your answers, I promise. All right, the x squareds cancel. This becomes a 25x. And then 3 minus 25 is a minus 22. Now that's a very strange looking remainder, but it is our remainder. So your answer is 4x minus 5 plus 25x minus 22, still being divided by x squared plus 2x minus 5. How beautiful. Give your parents nightmares by going home and showing them that. You should teach them. I think that'd be a fun bonding moment for everybody. I always think that'd be fun. What if we had your people come in on like an open house night and like you guys had to teach them to do something that we do? Like we'd pick something that's not like crazy, you know? Like long division. Everyone's had 4th grade long division. They should be able to figure out polynomial long division. Wouldn't that be fun? Maybe you'll get a little empathy, a little bonus points in their heart, you know? Oh, you poor kids. Alright, this is the newish stuff, right? This is the domain, range, vertical asymptote, horizontal asymptote, top heavy, bottom heavy. You're going to be using your yellow card, so you should have that handy. Anything here look particularly exciting?
No.
Oh, okay. Hey, number 8, it doesn't say the words, but what do you have to do to find the end behavior equation when you have a top heavy fraction like this? No, because you have a graphing calculator anyways. How do you, what's the end, no. I'll give you a code word for end behavior is horizontal asymptote or oblique asymptote. This is top heavy. It doesn't have a horizontal asymptote, but it has an oblique asymptote. How do you find it? No, we have to do division. You have to actually divide it. So you either do long or synthetic division. Totally up to you. Which one do you want to do? Of course. All right, so careful. There is a missing term here. Do you see it? We have a 1, a -5, but you have 0 x's and a 2. I know. All right, here we go. Should be a little more careful and double check all my math. It's okay. I think I'm all right. Am I all right? Cool. Now, I actually don't have to finish this. I can. I mean, just for good practice here. Because this part's going to be my remainder, right? And we don't actually use the remainder in this question. The end behavior equation, the reason that it's capitalized is because we are going to ding you if you don't write an equation for me. I get kids who write, oh, well, this means x squared minus x minus 4. And they write down x squared minus x minus 4. And then I have to be a jerk and highlight the word equation for you. Does this look like an equation to you? Thank you. You got to throw a y equals in front of it, okay? This is something you should be able to graph if you had to graph it. So it has to be an equation. That was for a different section that we are not testing tomorrow. Yep. Thank you. That's next week. This one's a little open-ended. You guys are going to graph, you're not going to graph me anything. You're going to write me an equation that has a removable discontinuity at x equals 5, so a hole, and a vertical asymptote at x equals -7. Okay, so I heard an x minus 5 on the bottom? On both. Okay. I agree. And then what else do I need? I love it. I think that's perfect. So the fact that they would cancel is the whole. And then remember, vertical asymptotes are where your denominator equals 0 factor comes up. So that's why Adam chose to put it in the denominator. Can someone come up with another example? Because it's not just this. There's a whole bunch of answers. These are horrible to grade. You FOIL it out. It says leave in factored form. So like, I think we have to build off of Adam's. I think we have to kind of start with what he had. But like, could I do like some random other thing up here? Like, would that change the fact that there's a hole in a vertical asymptote? No. So your gift to your teacher tomorrow is that you're not going to get too creative. Please. Because then I got to think really hard about whether you're right or not, and then I get crabby. So just like, stick to like boring level writing equations, okay? Like real boring. This one you have to find the hole. Remember what you got to do here? You got to factor. So, let's see. I'm feeling a 2x, but I might be wrong. And I'm wrong. Okay, it's 4x. How about we make this a +5 back here and a -1? That would add up to 19 on the arches. And then, denominator factor is much better. It's a x +7 and an x +5. So there definitely should be a removable discontinuity. So that's the removal of it, right? But then what I want to see from you guys is I want you to write your small version of it, the reduced version. This is important. So you know that the x value for the whole is located where? -5, good. But what about the y value? You got to plug it into this one. Okay. So plug in -5 to the reduced version of your rational. So you got what? -20 minus 1 over -5 plus 7. I can't read my own writing. -21 over 2. Which, guys, remember, you don't have like the calculator that you're comfortable with. So I would just leave it as -21 over 2. But if you wrote like -10.5, I'm okay with that. It's equivalent. Remember, you got little baby scientifics tomorrow. So I get kids every year. They're like, "Where's the math enter thing?" Like they don't have that on those. So you gotta use the fraction key if you're working with fractions. All right. old stuff. Knock it out of the park so we can stop harping on you. Plus, remember, all of Chapter 1, which Transformations is part of that, we're dunsies after next Friday, okay? All Chapter 1's expiring. And Chapter 2, guys, is not too far beyond that. It's almost November. Yay. All right.